All right. Hi, welcome everyone. So lessons 10 and 11 this week, and our volunteer is Sule. So Sule, let me turn it over to you. You can share your screen and you can say hi to everybody.
Okay. Hi, everyone. My name is Sule. I'm a data scientist up here in the Bay Area. Began my journey just shortly before the pandemic, and I'm excited to be presenting here in our meetup. Let me just share my screen. Okay. Can everyone see this fine? Okay. So as Ted mentioned, today we're going to be talking about working with grouping data, and also with subqueries. These are two lessons in our SQL book. The first section is on grouping data. As the name implies, group by is used for grouping data and then doing aggregations such as sum, count, average, etc. And the way we specify this is by using the group by clause. So when you do group by, we can contain as many columns as we want, even nested groups. So as you can imagine, group by clauses can get complicated. However, when you refer to the group by, it has to have a valid column name. So for example, you can't use the aggregation in the group by itself, and also cannot use aliases, just the actual column names. And we'll look at an example from the book. When it's used in the query, group by must include every column except the aggregates themselves. And something to note is that null values are grouped together. So as you can imagine, as we're learning the different types of operations we can learn in SQL, it's kind of, it's helpful to have an order, a way of remembering the order of the clauses. One I like to use is SFWGHO. So select from where group by having order. So group by comes after where and before having. If you search online, there's also phrases and different acronyms that people use to remember this. This is just one I personally find useful. Any questions so far?
I have various color commentary, but I'm going to let you sort of finish the group by section, and then I'm going to fill in certain things.
Okay. So one of the things we talk about in this section is filtering groups. When we talk about filtering, we already covered where. This is used to filter specific rows, but whenever you want to filter by group, we use the having clause. So just remember that where filters rows and having filters groups. So let's actually look at an example of this right now. And this is the same example from the book. So in this query, we want the vendor ID, and we also wanted to return the number of products for each vendor. This is coming from the products table. And specifically, we want products that are at least, let's say, $4. And we're grouping by this vendor ID. And for each one, it's returning where the vendor has at least 2 products. So we see that it gives us 2 vendors, and one has 2, one has 3 products. But when we remove the where clause, so we're not specifying that the product price has to be at least 4, we see that there's actually 3 results. So in this case, we didn't specify that we only wanted for rows that it was at least $4. So it just included all of these 3 results. So this was actually an example of using where and having together. I think the main thing to remember is just that where filters by rows and having filters by groups. Go down. Another thing to mention is that when we use group by, don't assume that the result you're going to get from the query is going to be in the order you're thinking about in your head. The order isn't necessarily going to be by whatever it's grouped by. So it's good to specify exactly, like, let's say, do you want the result by order ID? Do you want it by product price, etc.? So I think a general continuous theme in SQL as far as presenting and writing your queries is just remove all ambiguity so that it's returning what you actually wanted to return. Yeah. I know this section is kind of fast. Any questions, comments?
Any questions about the grouping? All right, so I'm going to add a few just comments on here. So hopefully you already got this, and this will just sort of reinforce some of the concepts. Last week, we already saw aggregate functions. You saw where we had a select, and it selected a count, or it selected a sum. So at its core, the difference is those queries will always return only exactly one row. Okay, so if you want to know, you know, the sum of all of the, how much people bought on all the orders, you can even add a where clause to give it like a specific subset, and that sum will just, yeah, it'll add up all the costs on the orders that you put in the where clause. But if you ever expect to get multiple rows back, that's where you have to use group by. So if you do something, I forget what your example was, Sule, if it was group by vendor or something like that, then for each vendor, group by vend ID. So for each vendor, you're going to get a row back in your group by results. Okay, and so the only way you can get multiple rows back is you have to use group by. Okay, I like how you said, Sule, right? The where clause limits the rows, and the having, limits the groups. I'll go back to what I've been saying since the first session, that when you run a select, SQL is a declarative language. It's not telling the computer, the database, how to go and get the rows you want. You're just telling it the qualities of the data that you want. Okay, so the where clause says, find me the set of rows that meet this criteria. Okay, those qualities. And it is going to find a set of rows that meet that. Only when it's done doing the select and the where will then the group by actually start to do any work whatsoever. And it'll group them by, in this case, the vendor ID. And then once it's done that and it's calculated these, in this case, counts, the various aggregate functions, then it's going to say, am I going to return all of those to the user, or do you want me to only return some of them? And so just like Sule said, in this case, it's only the ones that have count star greater than 2 are the ones that's going to be returned. So hopefully, again, that just reinforces everything that you already understood about this. One other thing I'll say is that if you think about it, the having clause, just like the one you've got on the screen right now, Sule, having count star greater than or equal to 2, the having clause can only have either an aggregate expression, like count of something, sum of something, right? Or a literal number. So you can say having count star greater than or equal to 2, you can say having count star greater than or equal to sum of something or other, but you can't just have a naked column name, because at this point, right, the only numbers you have left are the ones that are associated with groups. So having always needs basically aggregate functions for it to make sense, right? I want all the groups where this total meets some criteria. All right, so one other comment, one of my SQL annoyances, SQL's a very old language, is that when you use group by, you will see logically, if I said select vendor ID, if I'm going to do a group by vendor ID, if I said select vendor ID, comma count something or other, and then I said comma vendor name, that's just not going to work, because how can you group vendor name by vendor ID? If there's more than one row and they have different vendor names, what is it going to do? It doesn't know what to do. That's why you need to have an aggregate function, okay? But in some other languages, I'm not exactly sure about the different things like in pandas, but I know like I like the tidyverse, and in R, when I use dplyr, you say, this is what I want to group by, and it implicitly always returns those rows for you. And so you can say, I want to group by these 3 columns and just return me the count of rows. In SQL, you can't do that. If you want to see those 4 columns, you have to say, select column 1, column 2, column 3, comma, count of blah, blah, group by column 1, column 2, comma, column 3, okay? You have to repeat yourself. And then if you want it sorted by the exact same thing, then you have to say order by column 1, column 2, comma, column 3. So I often find when I'm doing some kind of group by, some kind of subtotals, that I'm repeating those 3 things 3 times, once in the select list, once in the group by, and once in the order by. And I personally find that kind of annoying. So I thought I would just share that with you. If you're wondering, like, is there a better way or whatever, like, it's not just you. It's SQL's a really old language, and it just won't do that sort of like implicit grouping for you. You just have to, I do a lot of copy and paste. And you know, it's not so bad when the column names are short, but if like, and to be clear, Sule, you mentioned that you can't use column aliases, but you can have expressions. It does not need to be just a basic column name. You can group by this column plus that column divided by a 3rd column, if that's what you want to do, okay? You can have any kind of expression. It just can't be aggregates, whereas the having it pretty much has to be aggregates. So that's just a little bit of extra color just in terms of like how all that works. It is quite common to see group bys in SQL queries. It's not like the only thing you'll see, but I would say it's pretty common. All right, so I hope that's useful. If that introduced any new questions, feel free to ask. Otherwise, I'll let Sule keep going.
Okay,
All right.
I guess I'll go on. All right, so the next lesson is on grouping data and additionally working with subqueries. As the name implies, a subquery is a query within a query, so a nested query. You can use this, for example, let's say we need information, we need to refer in a query to another table. That's where subquery comes in handy. And might be better to just show my example right now. So in this query, we want the order number. We're taking it from the order items table, but we're referring to it in the orders table. So in this example, we want customers who bought this product, RGAN01. But let's say that this specific product is in the order items table, but the customer ID is in the orders table. So in order to do that, in our select statement, we'll have to refer to the order number and specifically where the product ID matches. So in this case, we're returning this to this where clause here. So we're saying we're order number in 2007, 2008. Where that matches, we wanted to return the customer ID. So this query in total gives us these 2 customers. And just another breakdown for this is, okay, this is the full order items table, well, where the product ID matches. And we selected the order number specifically. This was returned to the orders table. So where the order number matched, we selected for the customer ID, which was the final result. So as you can imagine, a subquery is an extra step. So it's another thing that can also make your query be or look more complex. But it comes in useful when you need information from more than one table, whereas in some of the earlier sections, we were just referring to information in just one table, like getting this from just here. And along with referring to more than one table, you can have situations where you have a column that's the same name in both tables. In this case, it's important to specify specifically which table you're referring to in the query. Again, the role to remove all ambiguousness. And I think when it does this, if you don't specify the specific table, the specific column name, I believe that SQL will throw an error because it doesn't know if you're referring to this table or the customers table. And I think those were the main points I got from both sections. Any questions or comments as far as subqueries and grouping with them?
I have a question. So I don't think we've gotten to joins yet, but if you can just go over like a few of the advantages of using the query within a query compared to like joins. What are some like advantages of doing the join and compared to query within a query?
I think for me, what I can say is that I found join to be helpful if I want to take, like, if you want, you can specify if you want a left join, if you want a full join. So I think for me, visually, join is easier because I know that I'm returning all the matching records from this table or matching records from both tables. What do you think, Ted?
Yeah, so thanks for bringing up the question. If you read closely, the author tried to foreshadow joins and to say, hey, in this chapter, I'm going to teach you subqueries. I'm not saying that this is always the best way to do it. Okay. So a few things about subqueries. So one thing is you can use a subquery basically anywhere where you can have an expression in SQL, okay? Joins can only be used in a certain way in terms of joining the information from two tables together. So I'll give you an example of a place where I might tend to use a subquery, okay? I've got a query and it's returning the number of orders associated with each customer, okay? But in addition to the number of orders, I want to show what percentage each customer represents of all the orders. Okay. So one of the things I might have is some, count star of orders and then a group by customer ID. But I might also want to return a second column that says 100 times count star divided by what's the total number of orders overall. Well, how would I get that total number of orders overall? An easy way to do that is to have a subquery that says select count star total with no group by. I hope you guys are following. If not, I can actually like write something in chat. But so it's pretty, that's a reasonable situation that comes up for me relatively often, is that, you know, so if I want to know the number and that number as a percentage of the complete grand total, the easiest way to get that is with like a subquery. Okay.
And in your example, where in the main query do you put that subquery? Is it?
Yeah, so I'm gonna put it in the chat. So I would literally say select customer ID, count star, comma, 100. Sorry, you can't see until I hit enter. Okay, so that's the beginning of my query. All right, so I'm going to select the customer ID and the count, but then I'm also going to do 100 times the count divided by this subquery, which is select count star from orders. All right, and then the rest of my query is just going to be from orders group by customer ID, something like that.
Okay.
Okay.
Yeah, that helps.
So this is a case where I'm using a subquery there. One of the other things I was going to add about subqueries that this brings up is that unless you are using the subquery as part of an in, which was shown in this chapter, and it's actually a pretty common way that subqueries are used, okay? Unless you're using a subquery that's connected to an in, the subquery is only supposed to return one row, and usually only one column, only a single number. So you can see my subquery here is designed to return exactly one row and exactly one number. It's the grand total, the number of orders in the whole table. Okay, so you can imagine that generally speaking, your subquery use case is when you want a single number. That's not usually why you do table joins. Okay. So that helps kind of narrow down when would you use subqueries. You're using it because you want just a single number, or you're going to use it as the target of an in clause as part of your where. So where blah de blah in some dynamic list. Okay, you could have a static list if you knew in advance. So if I said, hey, I want to know the baseball records where the team is either Cleveland or New York, right? I can say we're team in Cleveland, comma, New York, close paren, right? But if I don't want it hard coded, if I want to have it be something dynamic, then like Sulei's example, you would put a subquery in there and it'll always return. So even, you know, if the number of rows returned might be different or whatever. Now, in that case, you're still, generally speaking, I can't think of an exception. You're only returning one column, but you are allowed to turn multiple rows. And basically, SQL turns that into the comma-separated list that would normally be hard-coded as part of your in. Does that make sense?
Yeah, and so and in your example in the chat,
yeah,
you're using that to give you a percentage?
Yes, because I'm doing the individual customer. You can't see if I highlight something in my chat. the first count star is how many orders for that customer, because there's a group by cust ID at the very end. The subquery select count star from orders is how many total out of all customers.
Yeah, okay.
And so it's going to do 100 times this customer's orders divided by everybody's orders. And so if there's 30 orders total and this customer had 3, then it's going to say 10%.
Wait, sorry. 100. So if there's, so why are you multiplying by 100?
Well, in this case, I'm doing percentages. So if
Oh.
this customer has 3 orders
Got it.
and there's 30
Okay.
total, you could represent it as 0.1, or if you want percentages, then I multiply by 100.
Okay, thank you.
And then this is my, again, you can't see if I highlight. The 100.0 is a little bit of a hack, but that's basically say I want a floating point number, because otherwise I don't want it to do integer division. I want it to do floating point division. But so that's why.
Okay.
All right. So
about
yeah, please.
optimization. So we here compute counts and percentages, and then we have this inside clause, inside query, subquery. So each time for each group, this inside query will be recalculated, or your value was so, you talk a lot about how smart this SQL compiler. So SQL compiler will realize that it is on the same query all the time, and it will compute the number, and it won't recompute it again.
Great question. So I was going to bring this up. So modern database systems are pretty smart. In this case, the first distinction I'm going to make, and you will see this terminology in some other more advanced database texts. They will talk about whether the subquery is correlated or uncorrelated. Okay, so uncorrelated basically means, like the example that I typed in the chat, nothing in the subquery references the outer query. There's no connection between the two of them at all. They're completely independent. And a modern database system, and as I've said in the past, I'm mostly a Microsoft SQL Server person, okay? I know for sure that in SQL Server, if you write this query, it's going to realize there's no connection between the individual rows and the subquery. Since there's no connection, it needs to only run it once, and it knows that total, I said 30 earlier when I was, giving a hypothetical. It knows that 30 is going to be the same for every single row, and it will be smart enough to run it only once, and it'll save that 30 in memory, and it'll just use it over and over and over and over and over again. I don't know exactly how it does it, but I just know that it'll only run the subquery once. Okay. There was an example in the chapter, and the author didn't go into it in much detail, but where inside the subquery, you mentioned something from the table in the main query. Okay, so now these are what's called a correlated subquery. Okay, so at this point, not only is it possible that the query will run, but it might be absolutely necessary, because there might be a particular value that's being used from the outer query inside the subquery. And if that's the case, if that value changes on every row, then it has no choice but to rerun the subquery for every row, because it needs to use a different value there. Okay, so I don't know why on earth you would ever do this, but in the inner query, I had select count star from orders. Okay, if I said select count star plus the customer ID that we're talking about from the outer query, okay, that customer ID is going to be different on every row. And that would turn this into a correlated subquery, and the database would largely have no choice but to rerun it once for every row. Did that answer your question, Maya?
Yes.
Yeah. So I'm not going to get too far into it, but it turns out that many simple correlated subqueries, next chapter we'll see, could be accomplished with a table join instead. And my general recommendation is, if that's the case, use a table join instead of using a subquery. But there are some slight nuances to it. it's also possible that if you're using not a high-end expensive vendor like Oracle or Microsoft SQL Server, if you're using MySQL, SQLite, they may not have quite all the optimizations. And in that case, the subquery might actually run slower if it doesn't have lots of heavy optimizations. So, so I would say that subqueries are kind of uncommon in production code, but there definitely is like a place for them. You probably should know how to do them. And generally speaking, anytime you have a subquery, there are going to be other options for how you could accomplish the same result. They may all have relatively equal running time, so it's not that any one of them is really truly better. It might just be more of like a style preference kind of a thing. So I'm just going to mention the book doesn't really get into I looked to see, doesn't really talk about temporary tables, and it has to mention variables, but it doesn't really mention them. But so if it's a single value, like the total number of orders here, I could have run that subquery just as a regular query and saved it manually in a variable that I've created in SQL. Okay. And so if I called that variable, total, then I could have just said, select customer ID, comma, count star, comma, 100 times count star divided by total. Okay. And I don't think the performance would be any different, but some people might prefer that to using a subquery. Other people might distinctly prefer the subquery. A lot of it just depends on personal style and the situation. If the subquery gets really long, so that it's like 10 lines of code, half a page, maybe you're better off separating it completely and sticking it, into a variable. There's also this thing that the book doesn't cover that's relatively new, called common table expressions, CTEs. And that's another way of saving off the results of a query into a temporary thing. So you will see there are alternate ways, but I would say that, say for example, we're talking about, you're going to interview and someone can ask you a SQL question. They can't really tell you that it's wrong for you to use that subquery there, just like I showed you. So that was kind of a long bit of explanation.
Maybe I didn't understand something, but cannot we use views?
Views won't really, I can't think of an example where views will really solve the problem for you. Views are basically just sort of like a saved off query. And so sometimes views have subqueries in them because you want to do something like show the count and show it as a percentage of the grand total. But having a view in and of itself won't change the fact that you either need to join two things or you need a subquery.
I remember seeing this clause, which would do exactly temporary subquery, which could be used with alias.
I do not know all the other database systems. In Microsoft SQL Server, when you see the with clause and then a query, that's this common table expression, CTE, that I'm talking about. It's basically like a temporary variable that's holding the result of that query just for the duration of whatever comes after the with. So there are different ways you can have sort of temporary variables and things. So I wouldn't expect you to really get quizzed on that. I mean, maybe, I don't know, maybe at this point, some people would say, these common table expressions, these CTEs, are common enough that they might expect you to know how to do them. If people are interested, we could do an additional lesson, like at the end, we can talk about CTEs. But the principle is a lot like just doing a subquery, except that instead of pasting the subquery right smack dab in the middle of your other query, you pull it up to the top and you give it a name. You say with this query as some, temporary name, and then you can use it later. And it doesn't sort of muck up your code by having to be pasted right darn in the middle of it.
I think they don't have case here too in the book.
You're right. I don't think I've seen that. I use case statements a lot. And so basically we've talked about expressions. We've said you can add columns and do other arithmetic. You can do some string manipulation. So if you're familiar with case statements in other languages, SQL has one. I think it's pretty much every vendor supports it. But basically you can just have a case statement with various true false tests, and each one of those when true says then this is the value that you return. So you use case statements inside of an expression. They're not like if statements, right? If statements tell you if something is true, do this command. Case statements are just part of an expression. And so
I mean the case one, and then etc.
Yeah, there's different syntax, but but if you're familiar with case in any other language, it generally works the same way. Is that the end result of a case statement is it returns a value, and it returns from whichever branch is the first branch that's true, and I end up using it a lot, and it just comes up that sometimes I'm trying to think of like a small example. Yeah, okay. Thank you, Ian. So one way you can do it is you can sort of chunk things. And so passing or failing a test, let's say. So you can just say if score greater than or equal to this number, then I want you to use the word pass. And if the score is less than that number, then I'm going to return the expression fail as a string, okay? And so the case statement would be looking at a column that has numbers in it, and it would be returning actually a string expression, either pass or fail. Okay. So that's a pretty common case where you're just, you're looking at something and you're just transforming it. Similar to that, you could do something where like you look at somebody's age, and if it's between 20 and 30, then you say 20s. If it's between 30 and 40, you say 30s. And so even though you have maybe 100 unique values for age, the case statement only has 10 different decades that it returns. You can have more complex criteria. I'm even thinking like something like this is a terrible example, but let's just say like you've got some information on people, and you say like case, if they're Asian, then I want you to return, are they Chinese, Japanese, or whatever. But if they're European, I just want you to say European. I don't know why you would do that, but you can do that in a case statement. You can just say treat certain things differently. And so anytime that comes up, that you just want something handled differently, something chunked or whatever, then, you can even do weird things like handle bad data a little bit sometimes with a case statement. So you could say like case, birthday, if you see XXX, change that to returning a null, because that's what it really should be. But it instead, it's actually an XXX. I don't know. There's all sorts of things you can do where you just, if you see this particular situation, return this value, else return, something else. hopefully one of those examples made sense for you guys. All right, any other questions? All right, I would recommend playing with the subqueries, try a few different things, especially the idea of a correlated subquery. And if you don't do it this week, then maybe wait, and next week we'll do the joins, and then you'll have a little bit better perspective of what your main alternative is. And then we can talk about some things that you might do with joins, some things that you might do with subquery, and some things that are like kind of gnarly. I was thinking, once we get past next week, you really will know most of all the basics. I mean, it's going to talk about some other things like, hey, how do you insert data and how do you create a table? But the main thing about how to write select statements will kind of be done. And so I might start sprinkling in some questions from wherever, you know, these different websites, HackerRank, LeetCode, whatever. And so there are going to be some examples where it's just not quite so obvious, like, hey, I'm just going to join the order and the order items table, and voila, I will have my answer.
And refresh my memory, you said to specifically correlated subqueries?
Correlated subqueries are where you're mentioning something from the outer query inside your subquery. And that means that it doesn't know if that whatever you're mentioning might be different on every row. I mean, it could be that it's the same, but it doesn't necessarily know for sure. And if that's the case, then it has to potentially rerun that subquery every row, just in case.
SQL Zoo has a good example with video where they explain what it is.
Oh.
I've seen on YouTube some explanations, not bad too. By the way, next week is my turn to give a presentation on joins and completely unrelated topic. If I ever step on somebody's toes, I apologize.
So I'm looking forward to next week. Thank you, Maya. Join is the big concept. This is what relational databases do well. Yeah, so I'm just looking. I don't see where SQL Zoo does subqueries, but maybe you can put something on our Slack if there's like a good link to like a page that talks about good stuff. All right, anything else?
Just thanks for the letter combinations, which helps to remember what is the order of SQL query, because I was wondering how other people do this.
You're welcome. I'm sure there's other ways people remember. That's just mine.
That's cool. Okay, so hope to see you guys next week, and yeah, I think a lot of some of these lessons have been hopefully pretty straightforward. It's just sort of memorizing the syntax and the order that things have to go in a SQL command. But definitely joins. I would say if you're learning and it's probably a good chapter not to miss, and also to do a little practicing, because definitely there's a lot of things that can have just less obvious, you know, what the right answer is. Whereas like group by, I mean, you know, you just need to know that you can group by one thing, or if you want, you can group by more than one thing. And I think you guys understand grouping, you know. All right, so we'll end the recording here and we'll finish for the week.